Hello everyone. In this video, we are going to understand Retrieval Augmented Generation, RAG for short, and see how to build a RAG pipeline using Langchain in Python. No machine learning background needed. Let's start from the beginning. So what exactly is RAG? On their own, language models only know what they were trained on. Ask one about your private documents and it simply can't answer. RAG solves this. It retrieves the relevant facts from your own data and feeds them to the model before it responds. The one idea powers many real products: customer support, knowledge search, legal review, healthcare, coding, and finance. Anywhere answers must come from specific documents, RAG shows up. So, how does a RAG pipeline actually work? It runs in a few clear steps. First, loading. We pull content from sources like PDFs, web pages, and text files and turn it all into plain text. Next, chunking. A long document is too big to handle at once, so we split it into smaller overlapping passages. The overlap matters. It keeps important context from being cut in half. Then we embed each chunk. Embedding turns text into vector, a list of numbers that captures its meaning. The key idea: chunks with similar meaning end up as nearby vectors. Those vectors get stored in a vector database. This is indexing. Think of it as a map where related ideas naturally cluster together, ready to be searched in an instant. Now the interesting part, retrieval. When a question comes in, we embed it too. Place it in the same space and find the nearest chunks using similarity search. The closest matches are the most relevant context for that question. Finally, generation. Those top chunks and the original question go to the model together, and it writes an answer grounded in your data, complete with citations. RAG is powerful, but it isn't magic. The answer is only as good as what retrieval finds. The model can still hallucinate if it misreads the context. Chunking is a balancing act. Too large adds noise, too small loses meaning. The index goes stale as your data changes, and every query adds a little cost and latency. Get these right, and your answers stay reliable. This is where Langchain comes in, a framework that wires all of these stages into a single chain, so you don't connect them by hand. A loader, a splitter, an embeddings model, a vector store, a retriever, and the model all ready made blocks. Link the retriever to the model and you have complete question answering chain, and you can swap any piece. Before the hands-on build, the practical part assumes a few things are already set up. Python and VS Code, an open API key, Docker, and a vector database running in a container, all coming together into your pipeline. And that's RAG, end to end. You're ready to build. If you would like a dedicated video on the setup steps, just drop in a comment below. Coming to the practical side of the things, I will be illustrating how a typical RAG pipeline works through this code on the screen, which I have developed in Python using Langchain. So I'll be going step by step to explain how this works to achieve a goal. But first we'll describe what that goal is and what is the business problem. So over here, if you go to the Explorer, what we have is a set of resumes from 5 fictitious candidates. And think of a situation where you are a hiring manager and you have to go through these resumes to understand which person would be the best fit to take an interview on a certain criterion. So in a realistic scenario, you would not just have these five, but like 50, 100,000 resumes. So the same pipeline can be used to actually scale it up till 1,000 resumes as well. But here, for the sake of simplicity, we are just working with five. So during the course of this practical side, we will be doing certain query against these five resumes to see which candidate is more suitable for a specific kind of query. And you'll see all that in action. So before we do that, I will first spend some time explaining the code. So we start with importing the libraries that are required. Now, as was explained in the theory section, that any working parts, the prerequisites, if you want them, if you want a deeper understanding of them, please drop in the comments below so I can plan tutorials specific to those working parts. But for now, we'll just assume that everybody understands these already. So we have to import these Langchain prerequisites, and we also have to load the API key for the LLM call. So we load everything through this load environment. Now, in this tutorial, what we will be doing is we'll be doing some querying, and that querying will be done through a RAG pipeline, and the RAG pipeline will throw some results at us. So these results will be nothing but the name of the candidates, and that requires some cleaning. So I have defined this function to do that cleaning for us when it provides the output. So we'll start with creating an instance for the LLM call with this OpenAI function. And this is the directory path in which we had created. We have put all the resumes. So if I just show you these, so these are all fictitious resumes. If you see through it, it looks like legit people who are applying for a data science position. For this candidate, they have some technical skills. There's a professional summary. There is some experience, and then education. Okay, so it says it's from Bets Pilani. So yeah, so you can see similarly for this other candidates, it's in the same format. So just reiterating that these are fictitious candidates, these are not actual people, and all these resumes are just fictitious as well, just to illustrate how this RAG pipeline works. So same have been uploaded here. Now, what we need to do first for a typical RAG pipeline to work is load all of these documents into the memory. So for that, we use the PyPDF directory loader. So a few minutes back, as I said, if you even work with 1,000 or more than 1,000 resumes, all you have to do is upload all of them over here. And this PyPDF directory loader will read all of them one by one and then load it into the memory. That is followed by doing a splitting of these documents into smaller parts, which are called chunks. So think of them as paragraphs. So the paragraphs which are split into smaller parts and have a degree of overlap with each other. So those have been defined through these parameters, chunk size and chunk overlap. And once the object is instantiated here as the splitter object, we pass on these objects for splitting. These objects here are nothing but these PDF documents. So it defines the chunk object. This is followed by creating the embedding model. So the embedding for these, so we use the text embedding 3 large embedding model from OpenAI to do the embedding task. That is followed by indexing. So what we do during indexing is once all of these documents have been splitted into chunks and the vector embeddings for them have been created, then they are being stored into a vector database. So here we define it. So this is the URL, and this is the name of the collection that we are creating, and we are also passing the embedding model here. Similarly, as a mirror image, we create something what is called as a retrieval vector DB. This is also coming from the same quadrant vector. But the difference here is here we are storing, so that's why you're using from documents functionality, and here we are retrieving, so we are using from existing collection. And if you see, the collection name is the same, which suggests that we are using the same physical location to fetch all that information. So going to the next part, we are doing the user querying. Over here, we're using similarity search to get the results out of all the querying that we'll do through this construct over here. And in this construct, whatever piece of information is being fetched, it will be passed through this text cleaner function, which I defined earlier, to extract the names. And this will be used by the LLM model. So here we are giving the LLM API call. I'm using ChatGPT 5. Again, to reiterate, to understand these working parts, if you are interested, just drop in the comments and I would be more than happy to create separate videos for this. But yeah, when you are defining a typical LLM API call, that's the way we do it. So we define the model, we define the roles, so it requires a system prompt along with the user prompt. So user prompt is nothing but the input that the user gives, and system prompt is the instructions that we give to the LLM as to how to process the user's instructions. So in the system prompt, we are giving this context we derived over here. This is basically the dictionary that the LLM will use to actually get the information required for us. And the whole thing will be running inside an infinite while loop, because I intend to query this thing multiple times before uh, trying to showcase what we are trying to achieve with this. So only when we press N or a no, it will stop querying. So before we start, let's just do one thing, which is run this command. So what was this and why we did it? So this is the command to create a Docker instance. Think of Docker as the hardware which will be housing this vector DB which we described here. So if I go to the Docker container, you can see over here, this is the vector DB which it houses over here, and it has been started like 23 seconds ago. And to see what is being stored, let's just first run the code. Let me make this a little bigger. Okay, now it is asking us to prompt something. We'll do that, but if you see, all of this information has been stored and these vector DBs have been created. So if you want to see the physical implementation of this, you can go to Quadrant. As you can see, it's hosted on localhost with the 6333 port number. And you can see the collection name rack tutorial. So rack tutorial is the collection name that we gave, and this is the same thing coming up here. Now what you want to see is how it looks from inside. So if you click on this, it will give you different payloads. So these are nothing but the chunks that we defined, and it has a lot of them, as you can see. Now what happens is, if you click on open graph, what it will give you is how this particular point is being connected with some other point. So if I hover over these points, you see that these points are changing over here. So these are nothing but different chunks and how they are connected through the similarity metric. So you can just play around with it, like which one is more similar. You can do that search, but that's not what we're going to do here. So coming back to this, if you see, we are doing a similarity search. So this is that similarity which is connecting all of those points through a graph. And when it tries to search, it will use those graphs to find similar answers. Okay, to see this whole thing in action, let's start querying. Okay, so let's start with, I think there was one candidate which was from Bits Pilani, if I remember. Yeah, the first one, right? Now, typically, we'll not look at this first and then query because it defeats the whole purpose. But I just wanted to confirm that, yeah, what I recall is correct. So let me query. Which candidate has graduated from its Pilani? So if I'm interested to ask and to know, amongst those 1,000, here we have just five, but let's say we had 1,000, more than 1,000 resumes. I'm interested to only look for candidates who are graduates from BITS Pilani. So this is showing the answer, this person. So if we see through the resumes, this person is from BITS Pilani, 2014 batch. Rest of these are like foreign candidates. So they are from foreign universities, University of Washington, Harvard, University of Texas, Austin, and Illinois. So yeah, this is how it is going to give answers. Now I want to do more searches, so let's do a yes. Now let me ask, I'm interested to interview a candidate who has experience, who has banking experience. So which candidate has worked with a bank? So it says Daniel Okafor. I've also given like a AI emoji here, so it's giving the answers. So Daniel Okafor, if I pronounce that correctly. So yeah, you do see that this person has worked with a bank, First Harbor Bank. So if I was interested to interview someone who had banking experience, I could just do a query like this, and it will start giving me the answers, and I can just go and look into that specific PDF from this bunch of 1,000 or more than 1,000 PDFs. Okay, let's now do some querying by skill. So let's continue. Um, which candidate has worked on time series forecasting? So now it's giving me two answers, Emma Larson and Marcus Strand. So let's check if that's the case. Where is Emma Larson? Yes, so Emma Larson does have time series forecasting experience, and the second one was Marcus Strand, right? So going to Marcus Strand, yes, this person also has time series forecasting experience. So just by querying here, I'm able to get to directly to the candidates from that bunch of uh, candidates. Let me do two more queries just to illustrate that this works. Which candidate has experience with, let's say I want something like AI or a computer vision. So let me just say computer vision. So it says Sophia Reyes. Let me go here. Yes. So this candidate Sophia Reyes does have experience with computer vision. I don't see that with the others. Yep. And then let me do one more query just to close this. So which candidate, I want to know which candidates have coding experience. So which candidate have worked with Python? Okay, so now it is giving all five because I think Python is anyways very common among data science applicants. So yeah, we would expect to see Python. So Python is here. It's here, uh, here as well. It's here, and yeah, yep, here. So it's a pretty common skill among data scientists on applicants. So this was expected. But yeah, just to showcase how this RAG pipeline works. So let me just close this now. So this is how a typical RAG pipeline works, and I hope this code was able to explain step by step how these different components work together to give you kind of the right answer. Now you could do some more responses, but it could produce some incorrect results, in which case you would have to then just optimize using these parameters. Over here, you keep changing and do some testing over here, like a parameter tuning with these, and that gives you much better results each time. So yeah, this was about how to build a typical rack pipeline in Python and how you can use it to make your job easier, as I just explained through this HR example. Thanks for watching this video. I hope you enjoyed watching it. If you found this video helpful and learned something new, then please like and share this video and subscribe to my channel. See you in the next video.